Hello everyone, I hope you're all doing good and had enough coffee. And I'm not trying to make it too long today to tell you what's been new at Grafana Labs since what happened from the last OSMC conference. My name is Sebastian Schubert. I'm a solutions engineer at Grafana Labs. I'm 30 years a firefighter, 26 years in monitoring observability. Know a lot of the folks here from NETWAYS conferences since ages, and really happy to be here today. That's about me. I'm going to show you a quick intro of what Grafana is, what you all might know. This is Grafana, the dashboarding solution, which I think almost everyone is familiar with. Any one of you not using Grafana or not heard of Grafana? Just a show of hands. Oh, excellent. Okay. So I don't know. Did you know that there's a lot more that Grafana is currently providing to the open source world? We have different platforms like Loki for our logs, we have Tempo for traces, Mimir for our metrics, and we have, since this year, we have a profiling solution called Pyroscope. Anyone aware of that we also fill that gap here? Or are you just, oh, Grafana, that's the dashboarding company, and that's it? We do a lot more than dashboards. We also build solutions for our customers in any part of the observability strategy that you might be following. Today we're going to talk about only the open source components, which I tried to highlight here with a circle, because we're at the open source monitoring conference and not at the paid by a vendor talk. So we're just going to go over what's been added to the Grafana stack and what's open source, so you can all use it for free and just get started with what Grafana is offering. So what happened at Grafana since the last year? You might be seeing it, I'm wearing the shirt. We have the 10th release since Grafana is already 10 years old, and we try to make one major release every year. We released Grafana 10 earlier this year with some big changes. Some of them were really, really nice. Some of them we got feedback from the customers that they are now struggling with navigation, things and like that. But I don't know, your journey might vary. We tried our best to improve the product, and we started with features like correlations between different data sources that we added to the product. So you're able to extract data from one data source. Say you have a trace or a SQL statement in your trace that you got from OpenTelemetry, and then you have the Postgres database hooked up as well to your Grafana instance. So you go to a trace, look, there's my SQL statement. I just run it within Grafana, and then you can just correlate the data and you see what actually would have been pulled out of the database, for example. This is something that we added in Grafana 10, and it's live for everyone. It's an open source feature. It's not a paid feature. And you can use it, and we highly encourage you to try to get the most of all the data sources that you have connected to the Grafana instance to work either way around, from Postgres to a trace, from a trace to a Postgres, or anything that you can hook up to Grafana. The next big thing that we try to make better or to try to improve is that we see that a lot of the audience that's using Grafana is not that technical, and they struggle with building dashboards. The out-of-the-box experience is great for a developer, for a technical person, but maybe persons from marketing department that just want to see how many people opened their emails or clicked on a campaign or whatever, they struggle with getting visibility from the data they have. So we try to revamp the whole onboarding for a new dashboard and try to improve it and give you suggestions how to work with the data that you already have. Any one of you been wondering what visualization type would be the best for this kind of data that I'm having? And going through all the visualizations till it looked pretty? Yeah, I see quite a few hands. We try to improve that. We have suggestions for you that should actually work on the data that you're having, and you get an overview. Hey, so that is the suggested, I hope you can see it all here. You have the data here, and this is how it looked like in a time series, in a gorge, in a stat where you have some historical data. So we try to give you a better out-of-the-box experience and to work with the data that you already have in your backends. For our tracing components, we heard the voice of the customers. They were complaining like, oh, it's kind of hard to search for data. We need something that we're familiar with. Most of the customers we have, they see PromQL or LogQL that we use for Prometheus-like databases or Loki databases, and we built something new called TraceQL that works on traces and has almost the same capabilities like the other query languages have. They have mathematical operations in there. They have label matching like you're used to from Prometheus or Kubernetes or anything else that uses labels. And that's how we try to integrate it and make the life even easier to find your traces and work on the traces instead of, oh, how do I query that? How do I find things like that? The next thing that we improved with Grafana over the year is we try to get more into we run things as code. And we would like to start with the developers that when they develop a dashboard and try to do this code, that they have some sort of recommendation how to work with. And most of our devs use VS Code. So we created a plugin for VS Code, and I hope you can see it, where you can create a dashboard within VS Code, and it will be live rendered in VS Code. This plugin has been released last week. It's out there on the marketplace. Just give it a try if you like, and also provide some feedback to our developers. They're keen to see it fly in production with customers. Talking about developers, since we've made massive changes to the underlying infrastructure in Grafana 10, with the remove of Angular as one of the most prominent JavaScript engines that we had for many of the visualizations, and going to React, we created other possibilities to create your own applications. If you've written your own plugin for Grafana or your own visualization, we've made something that's called Scenes, and we all put that in a new developer portal where we try to bundle all the information for the developers, where they have the complete documentation, they have the components library, they have access to Scenes, which is our new framework that we use, and we have also access to the new data plane framework that we use internally to abstract data from a backend to the front end, which has been ever since a part of the data plugin that's pulling the data, was also somehow responsible for displaying it. And we just cut that in half, and we have a data plane sitting in between that will take care of things like, oh, does this user have permission to query it? And so we have it in one central place to enforce permissions and have a better functionality to develop your own plugins, your own visualizations, if you would like to do that, and just to connect to one central piece. This is the data plane, and not to, oh, if I want to connect to Influx, I need to take care of that. And if I connect to Prometheus, I take care of that. That's all gone away. It's completely abstracted in the new data plane. And this can all be found on our new developer portal that we just set up for the developers. So that was it for Grafana, the visualization that you might already know, that we are having other products as well. We have Mimir, which is our solutions for metrics. At Grafana Labs, we try to run every software in a way that is horizontally scalable, and Mimir is our horizontally scalable version of Prometheus. It's been inspired by Cortex and Grafana Enterprise metrics, and Mimir is the base of all of that, and it scales easily to more than 1 billion active series. We see that with customers doing hundreds of billions of series in bigger Mimir clusters. We've made quite a lot of improvements over the year. Blazing fast query performance, when you read that, I don't know, last year we've not been that far as we are this year, and I'm going to show you what we also implemented into the product, so you can have an understanding of what's been going on and how will the product evolve in the next year, so you can get an understanding if that's the right fit for you, or if you say, oh, the guys at Grafana are doing something completely wrong. We have multi-tenancy. Everyone that's using a Prometheus system knows that multi-tenancy is not something that comes out of the box with Prometheus. You have to usually build your own multi-tenancy somewhere around Prometheus. There's no standard. Mimir has it all built in. And it also can take data from OpenTelemetry, Influx, Graphite, or Datadog. So if you're running in another ecosystem, you able to ingest all your metrics data using one of those telemetry protocols to send the data to Mimir and then query it in a Prometheus-like query language, which actually is PromQL. So what happened since last year? We had 4 big releases. We started working on the storage side where all the data resides. We use object storage for everything we store in Mimir. When you're doing it in a horizontal scaled way, you can also run it as a single binary in a single instance, but that's only for your development. When you run it in production, you always use some sort of object storage. And we try to stream the data between the components that interact with each other, and then due to that, we were able to reduce the memory usage by about 50%. Only when we started optimizing the read path between the storage and to the component that's actually trying to get the information. We also built the alert manager that you might know from the Prometheus ecosystems, and we're contributing to that as well. And due to customer demand, we also fixed one issue that was a longer-term wish of the community to have also WebEx. I know that there's at least one customer in here that uses WebEx. I don't know where you are, Luca, but yeah, there is. But this is something that we try to do. We build it in our systems, and then we try to upstream it back to the Prometheus ecosystem. The next big release was the 2.7 release, where we tried to optimize chunk fetching and caching. So when you think about data that's been lying on a disk somewhere, and you query it, you want to not query all of the whole, but you want to query some chunks and fetch them, and not big blocks, but more in a, how to say, I'm losing my English language. I might switch back to Bavarian. Zuzeln, anyone? When you're trying to consume the data in a way, and you okay, let me start over again. We've worked highly on the read path, where we first, after changing to a streaming model, we then changed the chunk fetching and caching mechanisms that we have built into the software, so you don't have that many reads on your object storage. Because when you use object storage at a provider like AWS or GCP, you usually pay per operation. It's something that's very common in the cloud. In a hyperscaler world, that you pay for everything that you have there. They try to charge you at the best. So that's why you try to do it more efficient. If you're running it on-prem, you might not run into those issues. But if you're running at a hyperscaler, you might want to optimize for everything, because their bill will end up, and it will be a massive amount of money that you will spend just for inefficiency. With 2.7, we then started our first support for native histograms. For all of you that are familiar with the Prometheus ecosystem, Prometheus has support for native histograms since last year, since the last Prometheus conference. And we also have that in Mimir as well. This is the first experimental support, because it's quite stable here, but with the open telemetry world that's catching up with Prometheus, and Prometheus catching up with OTIL, there's still some things that are yet to be built. With the 2.8 release, we finally built or released our Redis caching support, which adds a high amount of blazing fast queries that we can now achieve due to caching that's been in memory and not trying to hit data on the disk. Any one of you aware of what Redis is usually used for? Key value stores. Key value store doesn't translate normally to time series. We've built it in a way so you can optimize all of your reads for dashboards that you have quite often opened. When you have a start page where you have metrics that are heavily read from, then you will definitely see a big performance improvement from the Redis caching support. We also We also incorporated support for HashiCorp Vault. This was before HashiCorp did things to their licensing. We tried to work with HashiCorp to have support for Vault for various parts of the software, not only for the TLS stacks, but that's where we started for gRPC and TLS endpoints. And we tried to go in a more IT security friendly way of storing secrets and storing privacy relevant data. And that's when we added the support for HashiCorp Vault. We then added support for actually being able to query data from native histograms. With the release before that, that was just for the Prometheus conference, we were just able to get the and ingest the data, but we were not able to query it. And with 2.8, we had the first support for querying the native histograms and showing them back to the users. We also did a lot of optimizations between our query friend and our ruler. A ruler engine is something that evaluates the data that is coming in and applies some math on it, and then actually does alerting. I don't know who of you was in the talk here before, but this is all the math that Dave was talking about is happening in the ruler and all the statistical things. And we switched from HTTP to protobuf internally, and to be more efficient and to have a more efficient way to query thousands of rules per second that are being applied to the metrics that are ingested. 2.9 release was a very small release. The only thing we cared about back then actually was trying to use the API calls, which then translate down to costs, that you don't have to spend too many times on API calls, which are, when you're at the hyperscaler, driving your costs. And we supported streaming the data from our ingesters to our queries. The ingesters are the part of the software that take the metrics that are flowing in, and we have them in memory for a certain amount of time. So when you query rather actual data, like the last 5 minutes, they will sit in memory, so we don't need to check them at the object storage level. And this is where we also optimize for more recent data, so that we can also stream that data when you have, saying ingesting more than 1 million time series per minute. Then you will definitely support want to have that streaming setup enabled. Sorry. With the latest release, we had a lot of internal profiling that I was talking about, that we have the profiling Pyroscope now. We use it a lot at Grafana now, and from what we found with profiling, we were able to reduce the memory consumption by roughly 15%, which then also translate to your infrastructure costs, because you don't need to have that much memory in your clusters when you run the Mimir components. We improved the performance for OTLP ingestion. For those of you who are aware of the protocol details, OTLP uses another compression algorithm than what we usually use. Usually we use Snappy. They use SSDD. We improved this, and it also relates to costs. It's now cheaper for you to run it because you don't need that much CPU, and you're not wasting network bandwidth because of the more efficient way of compressing the data. And we now support the first experimental throw that we support native histograms in OpenTelemetry format as well. So the next component that is available from Grafana, and I think I'm running a bit out of time. I'm just going to go over it a bit more efficient. We have Loki for logs. I don't know if you've seen it. I've thrown some stickers on the tables there. There's a L for Loki. Loki is our solutions for logs, and that basically follows the same Prometheus-like label system. We only index the data that we take into account for querying, and we queried a bit other than the folks like Elastic or anything that's scene-based. We just index the labels, and then we just query the data. We do brute force on the data to find the needle in the haystack. For those people that are taking pictures, the slides will be available after the talk as well. So you don't need to take pictures. We can work with logs at scale without massive costs. We have, due to the fact that we run on object storage and on a horizontal scalable model, we can do a very, very, very scalable low latency write path. Usually you send the data and it's available within less than a second for querying already in our Loki systems. We have a flexible schema on read because we don't do any upfront schema definition for the data. We just take everything you throw at Loki and you will be able to query it. You don't need to define, oh, this log line looks like this. Just throw it at Loki. Loki will take care of it. And you can also access the logs with the same labels and set of metrics, meaning you have a service that's emitting metrics and logs. They use the same labels because they're coming from the same pot. You will be able to merge this information in the dashboard because you all know the labels that you have that are common, and then it's quite easy to work in that. And then the last thing that you can do is you can take information from a log and create a synthetic metric from that. And say you're storing the number of 500s per second or whatever, and you have a log line that's usually 200 kilobyte or 200 byte long. You store it in a metric. It's a Prometheus metric. Prometheus metric takes about 1.4 bytes of data on disk. Am I right about that, Alexander? Yeah. And so you store a very, very small amount. You just store it. It's a 500, and you don't care about, oh, what was the referrer, what was the browser, what was the user agent, blah, blah. You don't care about it. This is the 500. You create a metric from that and query that. It's way faster, and you have the information at hand when you need it. Loki looks like this, and when you ingest data, you have a timestamp with a nanosecond precision. It's typical float 64, like everything else in the Prometheus universe. You have some labels attached to that stream where you have information like your environment, instance, application, pod, whatever. And then you have the actual log line. You take the data, you push it to us. We just index the left part, and the right part is undexed. It will land on the disk. And when you query it, we just go through the timestamps. We slice the data. OK, this is the time range we're searching for. These are the labels we're searching for. And then we do a brute force over the content that we have. This is quite efficient because we can horizontally scale. And when you have like 64 Loki processes, they're all sharding the query, and they all only take a look. They look at a certain amount of time. You see, 60 minutes query. You have 64 queries. Everyone is looking at checking less than a minute of data, and so you have blazing fast query performance. I think I'm just gonna show you the slides and skip over them because we're then running out of time if I would tell everything that happened. We've made one major improvement. This is the support for TSDB, which means we use the same time series database index format as in Prometheus, which reduced our internal index that we built. When you say you pass a terabyte of data to us, the index for that was roughly about 100 megabytes before, and now we're down to 20 megabytes per terabyte that we store on disk. That's basically the biggest improvement, and when you experience with Loki was not that good with query performance, that might be due to the fact that you're not losing Loki 2.7 already. And with the next Loki release, which might happen next week, we will have some further improvements on the read path as well. Tempo is our solution for traces. We've heard a bit about traces today, about tracing in general. Traces, any one of you not using traces right now? Just in the typical infrastructure monitoring, like seeing metrics or so? Yeah. Most of you use traces, which is good. Traces have one big problem. You need to do something to get traces, and you have to instrument your applications. Usually you do this by a library that you install from the vendor that you have. And what we do, we take the traces that you emitted, and we can store them with Tempo. We have solutions for emitting traces, but Tempo is just a database for taking care of all of the traces that you have emitted. We can do exemplars. Exemplars are traces that are correlated to a metric. So at the time you emit a metric and you also emit a trace, to that time you can glue them together and you see, oh, I have a latency spike and I also have a trace at that time happening, so you can easily jump from a trace to a metric and visualize the information. I can show you later on at one of the booths, if you like, how to correlate that data. And what we would done with Tempo, we've built it with telemetry, open telemetry in mind, but we also taken care of Zipkin and Jaeger to support those, so you can send your Zipkin or Jaeger data also to Tempo, and as like the other solutions, it will be horizontally scalable and also quite nice to maintain. So if you do rolling upgrades, you won't have downtime with any of those horizontally scalable solutions that we have. I think the 25 minutes. Yes, okay. What happened? Since last year, we've done the 2.0 release, where we introduced TraceQL, and we switched to Apache Parquet as a default engine. Apache Parquet is quite commonly used as a columnar storage format for data, and we've now gone to that standard. We've also done some improvements regarding open telemetry, and we're now working on TraceQL to be a bit more, have more intrinsic data and also more structural operators. Like you can tell a trace, does it have childs? Is there a child for a trace, or which one is the parent to a trace? So you can find it quite easily. And we also have now support for traces that have spaces in their names, which is a quite common problem that people trying to instrument their, not their hello world, but the second program they write after hello world, and then you end up with data that you can't parse really. So we now have support for using spaces and names and proper quoting, so we can work on almost every traces that's been emitted. Coming to tracing, we've have another product. It's called Grafana Labs, which is also an open source component. Grafana Labs is the eBPF application auto information that we released. That we released in September during Prometheus conference. It will be GA anytime soon. Hint: there's a Grafana conference next week. We can auto-instrument your applications without doing anything to the application, more on an OS level. We're using eBPF for that, and it's available completely as open source, so you can use that and give it a try. Send your data to Tempo, for example. We have a really nice onboarding page where you can say, hey, just listen, there's something listening on port 443, just go and watch that process and tell us, and you will be able to have insights what's going on inside that process without instrumenting the process itself. Faro is the last one I want to add. Faro is our front-end browser monitoring, real-end user monitoring, or whatever you will call it. Every vendor calls it a bit different. It's a component that you can work with your applications. When you have web applications, you can instrument them and you can see what's happening in your browser. So the last mile, as we call it, in networking, that is the equivalent to that in the browser. Because you have a browser that's throwing an error because there's some problem in your application. You're calling endpoints, so you can't get a trace because you try to call an endpoint that's not available, so you won't get a trace. With browser-based monitoring, you are able to at least get the information that there is someone trying to reach an endpoint or there's a problem in your code, and you get that information as well. And the data is then stored within our logging and tracing engine. Most of that is logging. So when you would like to set that up yourself, you need a logging database like Loki and tracing like Tempo for that. With that, you can also have trace information available that you might have from any of your applications that's already been instrumented. You will be able to see the browser session hitting your database in one connected data stream. And you can also help your UX developers improve their optimizations if there's something broken, because that's usually the default when something breaks, that UX has been optimized. The last addition, I was referring to it earlier, is Grafana Pyroscope. We've acquired Pyroscope in March this year, and what you can do is you can do profiling on your applications. Say you have one application running, you do an update, and the next one is the next release of your application is taking double the amount of RAM, and you can then compare that information from a previous run over time, because we're doing constantly this profiling, and you can see, okay, after this this release, we have more memory consumption or more network usage and things like that, and then you can compare it and also have it as a part of your CI/CD pipeline, that you, when you're running tests before putting software to production, you could then easily spot, oh, there's the problem, and fix it before it hits production. With that being said, I will come to the last slides. We do have community meetups in several cities, Munich, Vienna, and Berlin. We try to run them on a regular cadence for anything that's somehow related to Grafana or open source ecosystems. So if you like to participate, we're always welcoming everyone. Or if you do want to run a meetup in your own city, then just come to us, and we will happily have a speaker and try to bring open source to other cities as well, not only Munich, Vienna, or Berlin. So for that being, I think we have 2 minutes for questions, or 3.
Yeah, thanks for the.
If there are any questions, you can also walk up or walk into me. I'll be around here, and just have a chat with me as well, if there's anything else.
Thank you.
Yeah.
Give a big applause to Basti.